Quiz 1.3 Notes. Use the remainder theorem to do the following problems using this function. So find the remainder of f of x, this, divided by x minus 2. You could use long division. That would work. It'd just take a lot longer. All right. You could do synthetic to do your long division to find your remainder. You could do that. And that's what we're going to do. But what remainder theorem is saying is, well, what makes this right here 0 is what you use for synthetic. But what makes this 0 in this situation is 2. So if you simply just plug 2 into the function, that is the remainder. So let me restate that. It's basically remainder theorem says if you do f of 2, this would be your remainder. You'll give you the remainder. Which, isn't that what you do when you are doing synthetic? Aren't you taking the 2 and putting all the coefficients of 2, negative 10, 12, and 0? Don't forget there's a term out here hiding. All right, so there's a 0 out there. Because we sometimes forget that. We sometimes forget there's something out here because there's no x's. The one without the x is missing. So we're going to do synthetic because when you do synthetic with a 2, that gives you the remainder. It also means is when you put 2 into a function, you get your remainder. You could also come up here and put 2 into this and plug it in that way. There's lots of ways to find this answer, to find the remainder. So let's do synthetic. Bring down the 2. Multiply 2 times 2 is 4. Negative 10 plus 4 is negative 6. 2 times negative 6 is negative 12. 12 plus negative 12 is 0. 2 times 0 is 0. 0 plus 0 is 0. So what is your remainder? There it is. Our remainder for this problem is 0. So find the remainder. The remainder is 0. What does that mean? Well, it means that this is a factor, if you didn't know that, because there's no remainder when you divided. So recap. To find the remainder, you are basically finding what makes this 0 is 2, and you're plugging in the function. You can plug in the function old school. You can plug it in using synthetic. There's 2 different ways to plug it in and find the remainder. All right, we're going to use remainder theorem to find f of negative 5. Here's f. So what does it mean? Well, to find f of negative 5, what you're basically doing is you're dividing by x plus 5. You're dividing by x plus 5, and the remainder is the value to this. It's kind of weird. But in the long haul, basically to find f of negative 5, you could put negative 5 here and here and crunch it. Or you can use synthetic to do it because the remainder of a division problem is the answer to f of something. So let's do negative 5 and do synthetic. I think it's easier. Then we have the 2, the negative 10, and the 12, and the 0. Don't forget the 0 at the end. All right, so bring down the 2. That leaves us the 2. Negative 5 times 2 is negative 10. Add down is negative 20. Negative 5 times negative 20 is positive 100. Positive 100. Add those together, you get 112. Negative 5 times 112 becomes negative 560. 0 plus negative 560 is negative 560. So what is the remainder? That is the remainder. So what is the answer of this? It is negative 560 is what we are looking for. Now again, you could have just put negative 5 to each of these instead of this, but I think this is a pretty cool method. And remainder theorem is basically saying if you want to find the remainder, or if you want to plug numbers in, you're really dividing. There's a division idea, and the remainder is the answer to a division of polynomials problems. Use remainder theorem again to verify that x plus 1 is a factor of f of x. So let's see if this is a factor. Well, to see if it's a factor, that means you should have 0 as a remainder. So we're trying to find what the remainder is. So we could long divide this by this and see if the remainder is 0. Or, like we said earlier, we can simply plug in what makes this 0. So what we can really just do is find f of negative 1. So if I simply find f of negative 1, that if this is 0, then it is a factor. But if it's anything else, it's not a factor. So in order to find that, let us simply do synthetic. I think synthetic would be a good one to do. So right there, we have 12, and don't forget your 0 at the end. Easy to forget that 0. All right, we're going to bring down the 2. 1 times 2 is 2. add those together, you get 8. 1 times 8 is 8, add those together, you get 20. 1 times 20 is 20, add those together, you get 20. So what we notice here is that's your remainder. So if this equals 20, well, to be a factor, shouldn't this equal 0? So is this a factor? No, it is not. So x plus 1 is not a factor of f of x. Why? Because the remainder is not 0. Instead of doing synthetic for all these problems like this, you could have simply plugged -1 into each piece and crunch it. And I just haven't been saying that, but really, f of -1 can also be this. So if you want to do that, or if you have a calculator and you're good with your calculator, you technically can type this into your calculator or do it by hand. And when you do that, you'll get 20. And you'll also see it's not 0, and that's why it's not a factor. But this idea, whenever you find f of, you can plug it in and crunch it, or you can use synthetic. These are interchangeable.